week is test on Tuesday. Yeah. Inverses of linear and quadratic. But also, Monday when we review, it will be my birthday. Exciting times, right? Did y'all want to have like a little party, you know? Y'all bring me gifts, $20 minimum, you know? Y'all bring me food, y'all bring me cake, y'all pay for the DJ. We'll go off campus. Now you look. No parties, but you can always write me a nice handwritten letter, say how awesome this class is. All right, well, anyways, today we're going to talk about verifying inverse functions. Did everybody actually turn in last week's warm-ups? For Monday, you can put sub. Tuesday, Wednesday, you can put no school. Monday, I was not feeling well, but I got over it over the next 2 days. So I'm back, feeling okay. Now, let's find the inverse of the following equation. First step, by the way, if you're taking a quiz, you want to do that first. So, hey. Do that quiz, please. First step, f of x turns into what letter? Y equals x plus 3 squared plus 8. And then again, x and y for inverses always switches, right? Okay. Is everyone getting this down for the warm-up, especially if you need to pass my class? All right, so x equals y plus 3 squared plus 8. Next step, what do I get rid of first? The 3, the squared, or the 8? The loner, 8, it's positive, so I'm going to subtract 8. Minus 8, minus 8. Remember, the minus 8 goes after the x. So x minus 8 equals y plus 3 squared. This is where it can get dicey, so everybody, do I get rid of the 3 or the squared first? Okay, so the 3 is inside of a parentheses. You can't get to it yet, so you get rid of the squared. Opposite of squared is square root. Okay, so you square root both sides all the way. Hey, what are you doing? Pencil, not a phone. So the square and the square root cancel out. And now we have x minus 8, square root of x minus 8 equals y plus 3. Last step, that plus 3 has got to go. The opposite of plus 3 is minus 3. And remember, it goes after the square root sign. Okay? So if I'm going to write my final step, it's f inverse x equals square root of x minus 8. And then the minus 3 goes after the square root sign. Okay? Cool. Now that's a review. That's stuff we've been doing. That's what we did last week. And today we're going to talk about verifying inverses. All right, 5.4 notes. Let me pull that up. Okay, this is not going to be that different than what we've been doing, just the questioning is different. So now the question is, can you verify that two things are inverses? Okay, so with tables, it's really easy. You already know how to do it. Two tables are inverse functions if the tables switch x and the y values. You already knew that, right? So look at example 1. Is this table exactly flipped over here? Yes. Good job. So are those inverse tables? Yes, they are. That was very, very easy, straightforward, right? No big deal. What about example 2 to the right of that? Is this table and the table to the right of it, are those flips of each other? I see 0, 1, flip it over, it's not negative 7, 0. So that's not the same. And then 1, negative 4, that's not the same when you flip it. No. So are they inverses? No. Okay, so is everyone able to tell? You just flip a table to see if it's an inverse and you're verifying it. You're just telling me yes it is or yes it is not, okay? Now what about graphs? So if two graphs are inverses if they reflect across the diagonal line, okay? So y'all remember looking like you had a graph, you had the diagonal line, and you'd have like two lines, or something like this, where it's like they would cross and be symmetrical across a diagonal line, okay? Well, what if the two graphs are separated like this? So example 1, we want to answer the first question. Do they look like they could be reflected across a diagonal line? So if I take this one on the left and I reflect it across the diagonal line, y equals x, what did give me this one over here? It looks like it could. Like, I don't know for sure, but I would say maybe. Okay, this line flipped over could be this one on the other side, but there's one way to find out for sure, right? So this is everyone listening, this is how you're verifying today, okay? Step 2, you're gonna make a table of points from each graph and see if they're flips. Because if they're flips, you know for sure it's an inverse, just like what we already talked about, okay? Here we go. Let's go to that first point. Right here, what is the coordinates of this point? Yeah. The x value is negative 3, 0, because it goes to the left. And then this point up here, what's the coordinates of this point? 0, 4. Okay. Now, I'm going to find the points on the other line and see if those are flips. Because if they're flips, then it's an inverse. Okay, let's start at the bottom here. What is this point down here? Zero, negative 4. And what about this point over here? 3 to the right, and then 0. Now you tell me, looking at these points, are these inverses? Negative 3, 0, 0, negative 4, that's not a flip. 0, 4, 3, 0, that's not a flip. They're kind of similar, but they're not the same. So they are not inverses. No. Okay, do you see how to tell for sure? Like, it kind of looked like it could have been. So we may have guessed yes, but when we looked at the numbers, it's a no. Okay, so look at the numbers. On the next one, okay, this graph's kind of cut off. It would keep going like this. Gosh. Okay, those look like they could be reflecting across a diagonal line. Maybe. Well, let's get some points. Everybody, check this out. What is the vertex of this one on the left? Right here. So the x value is negative 4. The y value is positive 4. And then the y-intercept right here, what's this coordinate? 0, comma 6, that's good. All right, now the other vertex on the blue line here, the x value is 4, the y value is negative 4. The x-intercept is at 6, comma 0. Okay, looking at those tables, are they inverses? The x and y switch, yes. Okay, so tables are pretty easy. Graphs are kind of mid-level. You gotta find some points and flip them, see if they work. See if they flip, actually. But what about for equations? So let me tell you, if you're given two equations and they ask you, are they inverses of each other? Here's what you're gonna do. You're gonna find the inverse of one and see, do you end up with the other, okay? So we're gonna find the inverse of f of x and then see if we end up with g of x. Okay, so first step, f of x turns into what letter? Y. Y equals 2x plus 3. What do I do with x and y? Switcheroo. Okay, what do I do first to solve for y? The loner is 3, so what do I do? I already switched them. Now how do I solve for y? What do I get rid of? Okay, how? Minus 3, minus 3. So x minus 3 over here equals 2y. How do I get rid of the 2? Divide by 2. Divide by 2. So I'm going to write f inverse x equals x minus 3 over 2. Now here's the question. Is that inverse of f inverse x the same as g of x? They look similar. What's different? F inverse x says x minus 3 over 2. G of x says x plus 3 over 2. Those are not exactly the same, so that is not an inverse. Do you see how that works? The inverse of one needs to give you the other, otherwise they're not inverse functions. Cool. Same thing with example 2. Let's try it. F of x turns into what letter? Y. Now this is just like what we did on our warm-up. We should be pros at this. Opposite, once I switch it to y, I need to switch x and y. Get rid of the loner minus 5 by adding 5. X plus 5 equals y plus 4 squared. Do I get rid of the squared or the 4? You can't touch the 4 yet because it's inside, so I square root to get rid of a square. And then, yeah, I got to get rid of that loner 4 by subtracting 4. Please remember, the minus 4 goes after the square root. So I get f inverse x square root of x plus 5, and after is a minus 4. Now, does that match g of x? F inverse of x matches g of x. Since those are the same, is it an inverse? Oh yeah. So, can you verify tables are inverses, graphs are inverses, and equations? I got a short assignment. You have today, but you also have tomorrow. But I'm also going to hopefully give you an updated grade tomorrow with these quizzes. And then we'll move on to reviewing on Monday. Birthday, and then test Tuesday. All right. I'm going to pass out the assignment. We'll get started here.